You don't really like
Right.
fun.
So 4 warm-up problems today. So I'm going to give them to you 2 at a time. So we'll go with the logarithmic warm-ups first, and then we got the other 2 warm-ups will be super duper fast. Okay. Remember, you will probably need a calculator of some kind in order to complete some of these problems. For instance, number 1. Okay. So in class here, preferably on an actual calculator. But if you don't have one and are too lazy to walk up to the front like Henry is right now and grab one off the desk, then remember you got to take your phone and you got to tip it to the side to get the scientific calculator. Okay? But that will not be an option tomorrow on the formative. Okay? Okay? So learn how to use a calculator now, as opposed to tomorrow when Mr. Roth and I will not be teaching you how to do the calculator stuff on the formative. First one, isolated, not isolated. It is, isn't it? Yeah, because the exponential term is all by itself. Yeah, so it's isolated. That was, remember, our first step. We got to get our exponented or our logarithmic term all by itself. So we're done. Step 2. What was step 2? Side note, where should these steps to solve, where should those go? Probably on your supplemental note sheet, because then when I ask these questions, you can say, oh, step 2, I need to do what? Switch forms with it, okay? So if I'm going to switch forms with this one, what does it switch to?
Log 2 15 equals x minus 8.
Log base 2 is what I heard you say?
Yes.
Of?
15.
That is how, hold on, that's how you say that. Log base 2 of 15. Because when you say log 215, that means the log of 215.
Got it.
Okay, right? Just so you know. Okay? We got to speak math too. Equals what, Logan?
Equals x minus 8.
Equals x minus 8. Okay? So, log base 2. What? Log base 2 of 15. What exponent do I have to put on 2 to get 15? Is it nice and easy?
Mm-hmm.
Nope, not nice and easy. Okay, so what should it be in between? Without even going to a calculator, what should it be in between? 2 to the first is? 2 to the first is?
2.
2. 2 to the second is?
4.
4. 2 to the third is?
8.
8. Okay. 2 to the fourth is?
16.
16. So what should it be between?
3 and 4.
3 and 4. Closer to 3, closer to 4. Closer to 3 or closer to 4? Should be closer to 4, right? Because 15 is only 1 away from 16. Okay? So how am I going to type in log base 2 of 15 on my handy dandy TI 30X 2S? How do I type it in? Log 15 or natural log 15 divided by natural log of 2. Making sure that we close the parentheses each time. That ends up giving me 3.906890596. Because if I didn't close that parentheses, then I would have gotten 1.69 something. And our pre-check told us that the 1.69 is wrong. Because it has to be in between 3 and 4, closer to 4 than it is. So that's a great pre-check to do, just a quick mental math there. Okay? Then, finish it off by finishing off by adding. So 11.907. Is there?
Because I remember, we gotta write up that whole three numbers.
Or keep it on your calculator. Because if you round early, then you will. You know what I mean? Yep. All right. Second one. Isolated. Yes or no? Yep, isolated. Okay. Step 2. Switch it to what? Yeah, what is it? Just read off me the equation.
Oh.
No.
Oh. 3 squared equals x minus 6.
There you go. 3 squared is?
9.
Finish it off by? $15 is x. 15 minus 6 is 9. What exponent do I have to put on 3 to get 9? 2 is 2 equal to 2. Okay. Second 2. I'll give you about 48 seconds to do those 2. Should take you longer to write them down than it should to do it. Because this should have been that 8 times. That's a 2. Okay, that's why. That couldn't be. I literally read it as a. That's why. What did you put away? Look at that, I'm still recording. That's awesome. All right, what do we got for the first one? Our old school exponent rules. X to the 8th. Yes. Second one. X to the 3rd. Yes. Okay. X to the 8th and X to the 3rd. When we're multiplying with the same base, we add exponents. When we're dividing with the same base, we subtract exponents. Okay. That'll come back to play here in a little bit. Okay? Oh, look at that. It's going to come back to play. That little bit was enough time for me to change slides. Okay? Now, from your Algebra 2 work that you did last school year, okay, you did some logarithmic type equations, and you learned about the 3 properties in logs. Okay? So the first property in logs is the product property. And the product property says that if you're adding 2 logs with the same base, you can multiply the arguments together. This is going to be the second most one that you use today. Take that back. This will probably be the first one, the mostest one that you use today is the product property. Okay? The quotient property says that if you're subtracting 2 logs with the same base, that you then divide the arguments. And you can combine logs. What we're trying to do is we're trying to condense our logs from 2 to 1. And we're trying to get that log isolated. And the only way that we can condense logs is by doing this. Not going anywhere. Because I haven't even gotten to the third one yet. And the last one that you learned back in Algebra 2 is the power property. And the power property says that if you have an exponent on your argument, you can take that exponent and you can multiply it by the beginning, or in the beginning of the log. And it will get you the same time. I'm not going anywhere with you. I'm not even anywhere near the board. Okay?
For some reason, I felt like
I know.
my mind felt like a remote on that.
I get it. I get it. I'm just walking to stay awake, you know? Okay? So, those three properties, I'm not going to ask you a question, final or tomorrow on formative. What is the product property? I'm not going to ask you that question to specifically write down what the property is. But I do expect you to know how to use it. And if we're adding, that goes with multiplication. If we're subtracting, that goes with division. Or vice versa. If we have two things that are being multiplied, we can break up the log, we can expand the logs, okay? Or we can condense the logs. I think on your homework, I think there were there a couple of expand and condense or not? I'm looking right here right now. Nope, good. I don't like those anyway. Just makes longer stuff for me to correct. Make sure that you got it all right. Okay? Good. All right, let's do this. Okay? So the third kind of problem. So we had exponentials. We had those yesterday. And there was only one kind of exponential problem. It's an exponential problem. Okay? Then yesterday we went to single logs. And we went to log equals log. Okay? This is two or more logs then that need to be solved because there's an extra third term. Okay? Basically what I'm saying is you've either got 3 logs or you've got 2 logs and just a number. Okay? Alright? If that's the case, in order to do step number 1 was what? Step number 1 was what? Isolate the log, right? In order to do that, we have to combine these 2 logs on one side. Or we might have to move a log first so that we have logs on both sides. Or excuse me, correction. Both logs on the same side. Brain was just going 18,000 miles a minute. I love this solving log stuff. Okay? Right? So we want to get logs on the same side, which then allows us to go back to that first one. So if I do this, this becomes log base 2 of x times x plus 1. And that equals 1. Power, excuse me, product. I'm going to say power play, that's hot. Product. Adding 2 logs means I can multiply the 2 items. Okay? Now it's a problem just like yesterday. I have now an isolated log. So after I isolate my log, what do?
You convert.
Switch forms. Switch forms. Okay. So what would the switchity swappity form be? Two to the first power equals x times the quantity x plus 1. Good job. Okay. Left side, 2 to the first power. What is 2 to the first power? 2. Right side, x times the quantity x plus 1. What is that? X squared plus x. Love it. So this is really 2 equals x squared plus x. PFD. Have you ever watched Scooby? But you know who Scooby is. Have you ever eaten a Scooby snack? Kind of a hidden gem in the tasty snack aisle. You know what I mean? So when I say rub roll, do you understand that process like Scooby? I can see that this reference is just you get it? Rub-roll? Rub-roll! Okay? What's the rub-roll part here? What do you really, honestly, truly want to do? You want to factor, right? But if I factor, what's going to happen? We're right back up to the step right above it. And why did we multiply it out if we're just going to turn right around and unmultiply it? Oh my gosh, not can we? We have to. Yep. We've got to set it equal 0 because it's a square. Okay? If it wasn't a square, then we could go and we could just go boom, boom, done. Right? But because it's a square, we got to set it equal to 0. So I got to subtract 2. Just because it's the fastest way to make it be 0 equals x squared plus x minus 2. Now, Claire, don't yell. I'm going to say an F word here. Okay? Now, it's probably not the F word that you're going to think about when I say my F word, but it's an F word. Okay? It's what, right? We have F. And I bet you're thinking of the other naughty F word. Probably with about 17 U's in Formula 1. That's 2 words. That's not 1 word at all. Some people in this room call it fire truck. Yeah, fire truck. Okay. All right. Does it, Claire? Did I give you enough time to figure out what this factors to be, or do you need some more time? Do you need to waste some more time? X plus 2x minus 1. Good job. Oh my gosh, now what?
You said both equal 0?
Set both equal to 0. Love it. And then what do I do with both of those? Solve them, right? So this gives me x equals 1. This gives me x equals negative 2. Now, Carter, I'm just going to talk to you. Okay? Everybody else, copy that. Everybody else, earmuffs, earplugs, whatever it is you're doing. Now, do you remember yesterday? Oh, man, you weren't here Monday. Yeah, I don't want to talk to you anymore. Mike, I'm going to talk to you. You can un-earmuff yourself. Okay? Everybody else is going to earmuff now. Do you remember what we did at the very last of our very last step? It was like step number 4. Check it. Now, this is important, Carter. Okay? Step number 4, he said, was check. Okay? Right? Now, I'm not going to lie to you. This is probably the mostest, importantest partest of the problem. You have to check both of them because one or both might drop out. If they both drop out, what's our answer? No solution. If one of them drops out and the other one works, then just that one is our answer. If you give me both of them and one of them is extraneous and doesn't work, you be wrong. And you're going to say, but I did it right. I'm going to say, yeah, up until step 4. Okay? All right? So we got to go back way up here. Way up here. And we have to say x equals negative 2. I'm going to check that. I'm going to go log base 2 of negative 2. Do I need to go any further, Will? Why? probably want to pay a little bit more attention, right? And stop playing like fancy face with everybody else around you, right? Well, you are actually. Let's be honest. Okay. First you were playing like grab hands with Sawyer. Now you're playing like maybe cuckoo faces at Ray. Okay. I have eyes and I have ears. Okay. So I'm going to give you one more chance to redeem yourself. Well, okay. What's wrong with log base 2 of negative 2? I can do lots of things with 2. Okay. You might want to look back in your notes from Friday. Okay. All right. Anybody else? We'll open it up to the floor.
Negative.
What's negative?
The got on. Can't remember which one. With the argument.
The argument. Can my argument be negative? No. Okay. So let's go back so this is for you now. You want to write this down, Will. Ready? Okay. What are the 2 conditions in logs? Base. What about the base? It's got to be positive, but can't be 0, can't be 1. What's my second condition about logs? What's my second condition about logs? The argument has to be positive. The argument can't be negative. If either one of those happen, done. Can't happen, doesn't work. So what about negative 2? Doesn't work. It's gone. Okay? Our other one was x equals 1. Log base 2 of 1. What exponent do I put on positive 2 to get 1? What exponent do I put on 2 to get 1? Say it louder, right? 0. This is equal to 0. Can it? Yeah, because it's the next one, right? Can exponents be negative? Yes. Can exponents be 0? Yes. Can exponents be 1? Yes. Okay. Exponents can be anything. 0 is an exponent. Okay. Then I go to the next one. Plus log base 2 of 1 plus 1. What's 1 plus 1? 2. What's the exponent that I have to put onto 2 to get 2? 1, right? Okay. So this log means 1. 0 plus 1. 1 is 1 equal to 1. Yes. So in my final answer is just x equals 1. If you give me negative 2 there, I will take many points off. Okay? I think there's one more. Oh, my Lanta, there is. I love it. Absolutely, positively love it. How about you try this one? So we can combine, we got 2 logs. We can combine this by multiplying the arguments because it's plus. So we're going to multiply those 2 arguments. So we get x minus 9 times x minus 3. And that, oops, I forgot the log part. Log base 3 of all of that still equals 2. Isolated by log. Okay. So now I can switch one. So I can get 3 squared equals x minus 9 times x minus 3. Okay. So then that's going to give me 9 over here. That's going to give me x squared minus 12x plus 27. Okay? Got to get it equal to 0, right? Because we got a square. Okay? So subtracting 9 from both sides. Now here is where I'm guessing that here was the first spot that we lost a couple of people, and I'm guessing that here is where we lost the rest. Are there two numbers in this very world that I can multiply together and get positive 18 and add them together and get negative 12? There are not, which means it is not factorable, which means what, Ray? We gotta do the quadratic formula. Which, by the by, probably should go on that supplemental note sheet, right? Because we've used it a couple of times this year. Yes? Okay. On your final, which is in 7 class periods. Okay? We got 6 classes left to go this semester, and then the final is our 7th one, right? In this room, by the way. Okay? Day 2, period 1 for me, day 2, period 3 for Ross. Okay? Okay? In here. On that final, you will get no extra, like there's no notes that will be on that final. Like no extra formulas, anything like that. Because you have your supplemental sheet. Okay? You guys are all young adults. Okay? This is a college level class. Typically college classes let you do something on the final, some kind of a note sheet. Some don't. But we're letting you use one. Okay? So here we go. Opposite of B would be positive 12. Plus minus big square root 12 squared minus 4 times A is 1 times C is 18 all over 2 times. Big old numbers. 4 times 18. That's 72. Okay. 144 is the first one. Yes? Negative 12 times negative 12 is positive 144. 144 minus 72 is square root of 72. Does 72 have any perfect square factors that go into it? What do you got? 2 and 36, because 36 is the biggest of the perfect squares, yes? Okay. So the square root of 72 breaks up to be that.
Memory I had.
The 3, 6, and 7. 12, 6, and 2. They're all outside numbers. Is there one number that goes into all of them? 2 goes into all of them. Okay? So if I paint is purple, black. Divide by 2, that gives me 1. Divide by 2, that gives me 3. Divide by 2, that gives me 6. Yes? Okay? So this gives me 6 plus minus 3 square roots of 2. Okay? Which is 2 answers, right? 6 plus 3 square roots of 2. And then 6 minus 3 square roots of 2. Now, this is the one that I'm worried about, right? Because it's the biggest subtraction, right? So what is 6 plus 3 square roots of 2 in a decimal approximation? Six plus 3 second x squared 2 equals. What you got? Just give me the 10.24 you said? Whoa! Is that going to work in our original problem? Because really we're looking for negative arguments. Am I going to get a negative argument with 10.24? No, because it's x minus 9, so it's 10.24 minus 9, still positive. And 10.24 minus 3, still positive. Yes? Okay, so we're good there. Okay? Now we gotta look at 6 minus 3 square roots of 2. What do we got for a decimal approximation of 6 minus 3 square roots of 2? 1.76. Okay, is that one going to work? Because 1.76 minus 9 is going to give me a negative argument, right? So that one doesn't work. So my answer here, my only answer is 6 plus 3 square roots of 2. Or I would also accept 10 point, Henry, do you still have it on your calculator? 26, so 10.243. Because we'll typically round to 3 up. With me? You now have enough information to do a pink sheet, which, by the way, Mr. Roth and I talked, if you want to turn in the pink sheet this week, that's fine, but if you don't, you can turn it in after break with no comment.